Hello, everyone. So today will be the last chance to ask any questions related to aggregation composition. I don't see any new questions on the Google Doc. I think after the announcement, I will see if anybody actually got any questions related to the lecture. That'll be the priority. If no, then we can. I do have something else on the agenda that we can go through. We'll see. Okay. Okay. Some quick announcement. So your lecture week number 7 about inheritance. That one has been released since Monday. This is a very important lecture, I would say, because starting from week number 7 for maybe at least 2 to 3 weeks, we're going to stay on the topic for inheritance. And they do build up one on another. So you definitely want to make sure you don't fall behind. If you only try to study them in a very short period of time, maybe before the next written test, it's very difficult for you to digest. So if you want my advice, I would say don't really procrastinate on studying the lecture. So it's under week number 7 over here. So it's this is what you're supposed to actually start studying for this week. And we'll discuss any questions that you might have about this lecture here next Wednesday and Thursday. And starting from week number 8, we'll actually continue for the topic in the inheritance, especially about typecasting and also polymorphic methods. Polymorphic method parameters and return values. So those are really some hard topics which you definitely need time to digest. So you really want to make some steady progress on your study. Okay, that's my advice. Okay, for your lab number 3, it's going to be due on Monday, right? It's specified on your lab manual. It's going to be on Monday, 2 p.m., right? EST. Right? Just make sure you actually make your submission, allow yourself enough time to submit. And for your written test number 2, right? It's about to happen in about 1 hour. Okay, and notice that the example questions that are made available to you is also going to become unavailable. It's going to be closed also in about an hour. So if you haven't tried that yet, you can do so if you want. You still got 1 more hour. And for your programming test number 2, it's going to happen next week about this time. You got more than 1 week, well, slightly more than 1 week to actually get prepared. I just released the some guide and also some practice test already. So if you go to the lecture site, go under week number 7, you will see the guide over here for the programming test 2. Okay, let me just mention very briefly, the policy will be mostly the same, but I will still encourage you to really go over them to make sure you don't get any penalty because you got violation of the policy. Now, what about the coverage for the test? It's going to be still about, you gotta write some object-oriented programs. So I think you don't really need to rewatch any of the tutorial videos, but you may just want to go over the code that you develop from lab 0 quickly. Just make sure you can still write the basic code, especially with the array. And you have to know how to program exceptions. You have to know how to program equals method, and also how to program copy constructor, especially for achieving composition. So I already made available some example test on the E-class already. So that's already, you can submit it for as many times as you like. And like last time, you will the practice test will be also closed for submission shortly before the actual programming test. For your lab number 2 and also lab number 3, I'll make the solution available to you hopefully by the end of Monday. So you still got 2 to 3 days to actually go over them to actually try to make yourself better prepared for the programming test. That's something I will try. Okay. Okay. Do we have any questions related to the course? Administrative questions? Anyone? I'll answer them first. Anyone? MD, please.
Yes, so this is not really a specific question. It is more of a general question about the labs.
Sure.
I just wanted to know, so since we don't submit our labs through eClass, we have to do it through the
web submit.
Web submit, yes. How are we able to check the marks that we
the marks, yes, very good question. I think me and the TA, we are now in the final stage of grading your lab 0, part 1, part 2, your lab 1, and also your programming test 1. I'm hoping to get all the results from the TA by the end of tomorrow. And then over the weekend, I'll try to tidy up things a little bit. I'll reach out to everybody early next week to actually tell you how you can check your mark and also check for the feedback. So the way you check for your mark would be very easy. All you gotta do is click on the link, which I will send to you. It's something called ePost. I'm not too sure if you use it in your first year. Anyway, it's gonna be a link, and then all you gotta do is to log in using your EECS login, which you already used for submitting your lab. That's about how you check your mark. In order to see the feedback, like how many tests will actually run, for example, and how many you actually pass or fail, and also some additional feedback by the TA. For that one, you will need to actually log in, remotely log in to your EECS account. And then you gotta run some command on the command line. But that's something I will actually make it clear when I reach out to you. So you can expect to hear back from me, hopefully by the middle of next week, maybe by Wednesday. I'll reach out to you about how you can check your marks.
Okay, thank you.
Okay, good. All right. It's a valid question. I know everybody is concerned about. That's definitely it's gonna happen soon. Okay, guys. Any other questions? Ahmed, please.
Hi, I'm not sure if I'm allowed to ask specific questions about Lab 3.
Lab 3? Do you want to ask anyway? Let me see if that's too specific, then maybe I'll refer you to my office hour. Why don't you ask first?
So it's about exceptions in test method, test floor 2.
Uh-huh.
So in line 155.
Okay. You mean on the starter test, right?
Yeah.
Can you give me just one moment? Let me open the file. Okay.
Okay.
Yeah. If the question is general enough, I can definitely answer that. If no, I'll just refer you to my office hour. We will help you either way. Just give me one moment. So it's your lab number 3. And then let me just open the starter tests. Give me one moment. Okay. Which line again?
Line 155.
155. Okay. You mean here?
It's actually in the comments on your screen. It's 153.
153. Okay, sure. What about it, please?
So it says that there's no error handling needed, but I can see that it's in a try-catch statement.
Okay, it's different. It's different. So the maximum number of units, I'll think about. I can give you a little bit more concrete hints for everybody. So here, when I say the maximum number of units allowed for a flower, you can think about a flower simply will store internally an array of units, and the size of the array is really about the maximum number of units you can store. For that part, you don't need to do any error handling. For example, let's say I forgot the magic number. Let's say if that's 20. So that means after you have stored 20 units into the array, if you're trying to add the 21st element into the array, you're supposed to get some array index out of bound exception. This is kind of consistent like a handle, with similar to your lab number 2. So you don't need to do any error handling for this. On the other hand, the try and catch block over here is more to do with about the maximum capacity of the flower. For example, if the flower actually got 500 square feet available, right? That's something you will set when you first create a flower. You can see here, right? That's the 500. It's a different magic number you have to watch out for. In that case, every time you're trying to add new units into onto the flower, that unit will take some area, right? For example, maybe the first one will be 25 square feet, and the second one will be maybe 50 square feet. And so you want to make sure that the added amount of all the areas for the units you have stored so far, they do not exceed, for example, the 500. So that's kind of the error handling you have to do. So they're different.
Okay, that makes sense.
Makes sense to you? Okay. It's general enough. I can clarify for everybody. That's okay. All right, good. Okay. Any other questions? I think that's about it for the announcement, right? So I think I didn't see any Google Doc questions any further. So you can still refer to the recording from yesterday. Let me just show to you quickly. If you go back to the lecture site, you can see under October 27th, under week number 6. Okay. You can go to the recording. Yesterday, I went over 4 different questions. They are rather straightforward, but if you're interested, you can also refer to them. That might help your understanding, might clarify your doubts. But for today, I'm thinking about the following, okay? Maybe this would be good for your written test. I think I can briefly go over the practice questions one by one. And then for some of the concept, I think you should know. Maybe I can emphasize them, but hopefully you already get a chance to try. But otherwise, you can skip this part for now, and then you can watch the recording later. Okay. But before I start going over the written test questions, I mean the practice one. Any other question you want to ask, either about Lab 3 or the lectures in general, I can give you priority before I go over the practice question. Anyone? I'll pause for a moment to let you get a chance to think, and then you can ask me first before I dive into the practice questions. Anybody?
Yeah, I have a question.
Go ahead, please.
So it's about a composition.
Okay.
So like when you're making a copy constructor,
Mm-hmm.
you're like making a new object. You want to do like a deep copy, so it's not shared aliases.
Mm-hmm.
So I was wondering if that object has more properties. Do you deep copy those too?
Okay, let's let me just for example, I kind of know what you're trying to ask. Maybe you're more asking about what will be the general steps for doing deep copy, right? Let me try to answer that briefly, and then you can tell me if I have answered your questions the way you expected. Let's say, for example, if you got a directory class, in the directory class, remember we actually got several attributes. We got the files array, and also we got the NOF, the number of files, and also the name, the string attributes. So the way we do a deep copy is by, we also have some helper constructor over here. That's what we're calling over here, right? There's a helper constructor. And then we simply say this part here, if you're given the name, you simply create a new string. The reason that we want to use a new keyword over here is because name is of string type, which is a reference value. So when you do a deep copy, you want to make sure for every reference type attributes, you want to call the corresponding copy constructor if available. If no, you may want to define that yourself. In this case, for the string attribute name, you can simply use the copy constructor of the string class that's already available to you. So you don't need to define one by yourself. Okay, that's number one. And then you can see here, we also try to, rather than just simply assign alias to the files array, which we also illustrated in other part of the lecture. So here, we're simply creating a new array, and then we go over each one of them. For each file that we want to copy, we also invoke the copy constructor for the file class. So when you're really doing a true decopy for true composition, you definitely want to call copy constructor from other classes. That's what you have to do. So I will refer you to maybe yesterday's recording, I think for the second or third part. So here I try to summarize the rules about copy constructor. So to make a deep copy, either you're dealing with primitive attributes or you're dealing with reference type attributes. In that case, for the primitive, you can just use a reference assign, like a assignment operator, which will just copy the value. Okay. On the other hand, if you got reference attributes, in that case, not only that you have to use an assignment operator, but you also need to invoke the corresponding copy constructor to make sure the deep copy does not just stop at this current level. It will definitely continue to all the lower level if you got different objects layered. Does that kind of answer your question?
Yeah. So it's kind of like when you do a copy constructor, like that will also call another copy constructor.
Yes, that's correct. That's exactly right. Yes. Of course, it depends on the object structure you have. And I believe, yeah, for your lab number 3, you definitely have to do that because you got different level. You got blueprints, you got floor, you also got units. You got at least 3 levels. So if you really want to do a copy constructor for true composition, you have to make sure at each of the 3 layers, you got the copy constructor. And you will see something similar for your practice programming test number 2. Okay.
Right.
Good. Okay. John.
Thank you.
Yeah, no problem. John, go ahead.
The question is related to this as well, is that when we're dealing with like creating copy constructors with deep copies and multiple layers, if at some layer in those like exceptions are being thrown, how do we deal with that?
If at some layer, I can tell, that's a good question. You're basically asking, I can answer you a little bit more in general, but I think if you got some very specific example that we can also talk about. I think the question is, actually, let me just put it here just for today, right? Okay. So John's question was, what if copy constructor throws an exception. Throws an exception. Okay, let's see. Okay, let me just use the names of the classes that you're actually in your lab 3. Doesn't really mean you have to implement that way. I'm just saying, for example. Okay, let's say, for example, if you want to say new and then blueprint. Okay, and over here you simply get BP, another blueprint objects. Apparently we're calling the copy constructor. And then let's just talk about the layers first, and then we'll talk about how exception might happen and how you can handle with that. And let's say in turn is actually going to have some code, and then we are also going to call new, and then let's say floor. And then you might have some F over here, right? And similarly, in turn is also going to trigger some code, and one of them might be that you want to create a new units, for example, like that. And then maybe U. Okay, and let's say after units, you don't have any further layer of the object, so we kind of stop there. Okay, so we got 3 copy constructor over here. We got 1 here. Let me just say we got 1 here. We got 1 here, and we got the third one over here. We got 3 copy constructor and 3 layers. So the question was, what if exception was thrown in one of the layers? For example, let's say if somehow, let's say in the header of the floor, let's say for this particular one, let's say it is declared as, let's say simply say public, and then floor, and then you have floor F, okay, and then let's say as part of its signature, you might say throws over here. Let me just say some exception, just make it a little bit more abstract, general. Okay, and then so inside the code over here, you will expect the throw. You will say throw new some exception at some point under some condition. Let's say that's the case. So if this is this particular copy constructor might throw some exception, so that means any caller who actually uses it is going to be subject to the catch or specify requirements, as we learned from lecture 2A, right? So there will be several consequences. Okay, let's say this. So now if you look at the blueprint, so we know that number 1, this is the caller of the copy constructor floor, right? Okay, that's number 1. And the consequence of that is it will be subject to the catch or specify requirements. Okay, and now the 2.1 and 2.2 are basically either one, right? But I wouldn't do both. So John, let me ask you this. If I know that blueprint constructor is actually going to call someone like a floor copy constructor who might actually throw this exception over here. So what are my options? What can I do?
Either throw it again or catch it.
Catch it. Okay, sure. So let's say throw again. In that case, yeah. In that case, one option would be you can say you declare. You can say public. So you can say public over here, and then blueprint, and then you'd say, of course, that's blueprint. BP over here, you will simply say throws, meaning that you're propagating the exception to whoever the caller is for this blueprint copy constructor. That's what you're doing. Throws some exception. Yeah, this is also something we actually use an example to demonstrate. And eventually, you might simply propagate this exception all the way to maybe the JUnit test class or maybe the console application class, the main method, right? That's 2.1. So 2.2 is going to be something like this. You're going to say you still have public and then blueprint. Now maybe P should be lowercase, but let's not worry about it. And then here blueprint. And if we choose to actually catch it, So that means we don't need to specify in the header about this throws, right? We don't need to. So what we can do is over here, we will expect somewhere in the code, we're going to say try. And then try, we're going to try this particular copy constructor. Try, and then you're going to say new floor. And then F, right? And then you're going to say catch. Okay, try and catch. And catch will just be some exception over here, right? It's going to match the name. I'll just say SE, some exception. Okay, and then etc. So now I can notice the difference between these two options, well, pretty much confirming what we learned earlier. If you simply say throws some exception, in that case, in the body of this copy constructor over here, we can just invoke the new floor without the try and catch, right? On the other hand, if we don't really want to say as part of the header of the blueprint, we don't want to really say throws some exception. We want to handle the exception right away in this particular copy constructor. What we can do is we can say the try and catch inside the body of this copy constructor. And then in that case, we handle that right away. And in option 2.2, any caller of this copy constructor over here, they would not be aware of the some exception because it has been handled already. So John, does it make sense to you?
Yeah, but can we assume that whatever we receive in won't trigger any exceptions or no?
Say that again. I don't quite catch you.
So can we assume that whatever we pass in, that like let's say that blueprint we pass in isn't gonna cause any exceptions, because if it did, it would have it would have been caught before when it was created.
So basically when you actually invoke, let's say use a new keyword to invoke the blueprint constructor. So whenever you're calling this, depending on you're in 2.1 or 2.2, in the case you're in 2.1, whoever is calling this also is subject to the catch or specify requirements, right? Again, so meaning that they either have to wrap this around try and catch, or they can simply say throws some exception for that particular caller's header, either one. But whether the argument over here BP, whether or not it will trigger the some exception at this level over here, we don't know. So that's why we gotta consider both cases.
Okay, perfect. Yeah, I understand.
Hopefully makes sense. Yeah, this one is a very good question here. In general, this might happen because whenever an exception might happen, it may not just happen in the case of mutator or accessor. It can definitely happen in the constructor. Especially now we got copy constructor and also exception handling playing together. I think as long as you know about this principle over here, and you should know how to move on about how to implement it. Okay. Okay, good. All right, another John. John Mai, please.
Hello.
Hi. Go ahead, please.
I'm sorry, wait, I just want to quickly ask, is it okay if I ask practice the written test questions or no?
Oh, sorry, say it again. You want to ask about?
I want to ask about the practice written 2 questions.
Oh yeah, sure. Yeah, practice.
Okay.
You know what? That will be the next item in the agenda. I'm gonna go over the practice question for written test 2 one by one. I'll do that. So I would say maybe hold on your questions. For now, I just want to see if there's any other questions related to the lectures or other concept in general before I move on to that item. Just bear with.
Sure thing.
Okay, good. All right, guys. Let me ask you again. You can definitely ask me later. Is there any question you want to ask me about aggregation, composition, or any earlier lecture before I go on to talk about your practice written test 2?
Oh, yes. Sorry. Quick question.
Okay, yeah.
You said something about static types and dynamic types. I didn't quite understand what you meant by that term.
Okay, I can mention that very quickly, but I think you will actually have even more detailed and complete answer by following week number 7 lecture, when we already start talking about inheritance. I'll also refer you to the lecture over there. But very quickly, you can think about the way you can tell static type and dynamic type is by looking at the syntax. So for example, let me use the example from your week number 7 lecture. Okay, so let's say we got the following line. We say students, let's say S, okay, is assigned to new, let's say resident students. And let's say maybe Jin. Okay, so this is a very typical line you have to write to create an object. What you might find a little bit puzzling is like this. Before, maybe even before today, I think always when you see declare type and also the calling the constructor, you always see these two usually are the same, but they don't have to be. Okay, I would say what you have look at about the two being the same up to today is not very common. The more common scenario should be these two types are actually different. Okay, so the way to see that is you can see, think about this is the declare type. So that's the declare type. And in the case of reference variable, we'll say that's also static type. And the static type never changes. And to go a little bit more, that's also something I spoke about in the equals method lecture. It determines the range of attributes and methods callable on the variable s over here. And if you follow through the lecture for week number 7, the range of attributes and methods, so this is so-called expectation. So that's why static type is so important. On the one hand, static type is very easy to identify because every variable, reference variable, only got one static type, and once it's declared, it never changes. Okay. However, what's really tricky is about to figure out exactly the expectation for your static type. Right. That's something you can look at week number 7 lecture. About dynamic type, very quickly. Dynamic type over here, it's actually about the objects that's being that your reference variable is now pointing to. For example, after this line, you know that S is really pointing to this object over here, which will be of type resident students over here. So I'll just say RS for short. Resident students. So after this particular line, we know that dynamic type for S, dynamic type is now resident students. On the other hand, it doesn't really mean we cannot write another line to say the following. We say S is assigned to new. Okay, we are not redeclaring the variable. We are just assigning that to a new objects. Let's say non-resident students. And maybe I would just say maybe Alan. Okay, so after you do this, you're saying the following. S, rather than pointing to a resident students, it is now going to point to a non-resident students objects, right? It's an objects of different type. And after this line, you will know that dynamic type of S has changed from resident students into non-resident students. And there's another concept called dynamic binding, which I also explained in detail in week number 7. So I think, John, it will be the best. Taking this intuition over here and try to go through the lecture for week number 7, you will find the complete answer there.
Got it. Thank you. I really appreciate the
No problem. Okay, good. Okay. Guys, if you're completely lost, hopefully that will give you more motivation to go over week number 7. It's crucial. All right. I know written tests and programming tests are important, but learning about inheritance, I would say, is even more important to take away for this course. Okay. All right, guys. Any more questions before I go on to the practice test for your written test too? Hopefully that will also help you for the coming one. Okay. So John, do you still have questions, or just forgot to raise your lower down your hand?
Just a quick question. Sorry.
Yeah, go ahead.
So I heard first static type. Static type is also used for like when we're detecting types for like as used for parameters, right? We have overloaded methods, different methods.
That's correct.
Static type is what's used, right? Okay. But for like dot equals, what's use the dynamic type, right? The dynamic type of the first object in the dot, and like let's say like we use the dynamic type of the context object when we're using the equals method, correct?
Mm-hmm.
Okay. Just checking. And then for when we're doing like reassigning it to different classes, like in that example, you had resident student and non-resident student. But if the static type of that student was, let's say, like resident, like if it was resident student S equals new resident student and then Jim, we couldn't then reassign it into non-resident student, right?
Correct. You cannot do that.
Okay.
That's correct. Yeah, so guys, maybe I wouldn't go any further about what John said because that one is exactly covered in the week number 7 lecture. So I would say week number 7, and then so there is one video called the intuition of polymorphism. Okay, so once you follow this part of the lecture, you will be able to understand what John was just saying. Basically, just about can you actually assign one variable to another? So there's certain rule that will guide actually such assignments. Okay. Anyway, let me just say one more thing. So let me just go back here, just make some connection here, objects and also OBJ, right? So this is more like a revisit, just to revisit quickly about the equals method over here. Okay, so let's say at the runtime, you're trying to say, for example, P1 dot equals P2. Okay, let's say this is how you call the equals method. And apparently P2 over here is the arguments, right? And because of call by value, right? So call by value is going to make sure you do the following assignment. You're going to say OBJ is assigned to P2, right? That's call by value. Let's talk about it very quickly. And I will draw the picture, and then there's something for you to think about as well. So let's say maybe P1, the context object is pointing to some point object over here. P1 is not very, P1 is like a this, right? So maybe P1 over here, it could be maybe point V1, okay? So dynamic type for P1 is actually point V1. Let's say P2 over here is pointing to dynamically another object over here. Let's say it's point V2. So let me summarize what has been said so far. Dynamic type of P1 is point V1. Dynamic type of P2 is actually point V2. Okay, so far. And then because of call by value, what we're doing is we're assigning P2 to OBJ. So that means OBJ is actually going to point to wherever P2 is pointing to. However, OBJ was declared to be objects. So it's really important to say the following. OBJ over here, to be more precise, we have to know what's its static type and what's its dynamic type. Static type for OBJ is objects, right? It's declared. Dynamic type for OBJ is point V2. So this is why we said before, you simply cannot say, for example, obj dot get x. Also, if you try obj dot get y, also you cannot do that because you just cannot. These are not okay because obj, the static type over here, does not support, does not declare, or does not support x and y. Object is really the least available classes that can actually allow you to call attributes and methods. Okay, and that's why at some point over here you will need a typecast. And for the typecast, I would say refer back to the equals lecture if you got any doubts. But we're gonna revisit typecasting again in week number 8 in the coming week for inheritance. All right, something I want to remind everybody quickly. Okay, so now let me now go over maybe the written test, the practice written test one by one quickly. Okay, the first one over here, this one's interesting. Okay, here I'm just using the same example here. We got students, we got course, and also we got faculty over here, right? And we assume that for every private attributes, we got a corresponding public accessor. For example, for ID over here, that's private, so you can also use get ID. Okay, so there is one principle you have to know. Okay, let me just write down the principle, which will be useful when we actually go over the question. So here's the principle. So here, if the context objects is of the type or class, right? Sometimes we simply use class and type interchangeably. If the context object is of the type or class where an attributes, to be more precise, where a private attribute is declared, it is allowed to use the dot notation to access it. And the it over here is really the private attributes. Okay, a private attributes, and then if the context object is where it is declared, right? That's the important principle, and that's also something I spoke about in the lecture for aggregation. You can rewatch the part of the lecture about the example. Okay, let's now go over some of them, maybe each one by one. So now we are in the context of the course class, right? So let's say this is how we started with. This is where we are. Okay, let's now go from here. So I wouldn't really go as much as detail as what I did in the lecture, but at least you will see the idea. Okay. Is this valid over here? So we simply go for prof, right? So we do have prof, okay, and then prof will lead us to faculty, right? So we go to the faculty class, and then we go for TE. However, what's the type for TE? It's private, right? So what you want to really know is, you can see here, let me just make a note. Prof over here, just this part over here, is of type faculty. And then, can we actually refer to TE, which is a private attribute over here? The answer is we cannot, according to this principle, because remember the context class right now is actually course, so you cannot really refer to the title private attributes. Sorry, you cannot refer to the TE private attributes in the context of a course class. You cannot do that. Okay, let me write it down, and I'll see if you got any questions. Cannot access private attributes TE in course, right? This is the context class that we are talking about, because TE, the private attributes, is not declared in course. Any question about option A? So A is not valid, right? So choose all that are invalid. So A should be chosen. Okay, any questions so far?
Why doesn't the context switch? Because you did say it was faculty, so shouldn't the context switch?
So here, so there are two kind of contexts we're talking about over here. Okay, let me be more precise. Look at over here how the question starts. Let's say we are now in the context of some methods in the course class. So to be more precise, you want to imagine the following. Think about what you're doing is, in the course class, we may have some method. For example, just a void and maybe n. Just imagine that. And then each of the expression I'm talking about over here, they are defining in the body of this particular method in the course class. Okay, so now the principle is easy. Anytime in the dot notation you're writing over here, whenever you're referring to any attributes that's actually private, if that attribute is not declared in this particular context class that we start with, then you cannot access it. So this is why we can say prof over here, because prof was declared as an attribute even though that's private in the starting class over here. On the other hand, over here, when we say prof.te, even though we already switched the navigation context to faculty, but now can we really get access to TE, which is private? The answer is we cannot, because our starting point is actually course, and course is not where TE was declared, so you still cannot get access to it. The only thing you can do is to say, rather than saying TE, you gotta say dot get TE. Does it make sense to you?
Yeah, I think we just need to see a little bit more examples.
Yeah, I just need more example. Okay, let's see a little bit more. Okay, let's see the next one. So here, prof will be okay because prof is indeed an attribute that's declared in the course class, even though it's private. So this part is okay. And can we say TE? No, this part is not okay because TE is referring to a private attributes in the faculty class, and the faculty is not the starting context. So that's why it's not good. What you can say is prof.getTE, so that'll be fine. Okay. Okay, and this keyword is simply implicit, so we can always add it or leave it, right? So okay, this.prof is okay, right? And now you can say this.prof.getTE. So now it's fine because this.prof, what's its type? This.prof is of type faculty, right? So this part here is going to be faculty. And since now we are switching to a context that's different from the starting one, which is course, we can only refer to public stuff, public attributes or public method. But typically, we don't really have public attributes. That's not a very good practice. So now, can we say getTE? Indeed, we can do that because that's a public accessor that we assume. So that's why can you say getTE over here? That's okay. So this is valid because it is public. And then you're going to say index 1. So getTE is going to give you a course array, and then you're going to say index 1. Index 1, we assume the index to be just valid. But as far as compilation is concerned, we don't really worry about if that's valid or not. We can assume that's actually valid. And then when you go to index 1, it's going to be a course. So we are now back to the course. Does course have an ID attributes? No, it doesn't. It only got title. So that's why B is also not valid. C here. So that should be chosen as well. Okay. And also, of course, B before it was using TE in the context of faculty. So that's not chosen either. Sorry, that's also chosen. Any question about A, B, and C? It's now time to ask. Any question? Okay. Let's now go on to see the next one. So prof is okay from the course. getTE is very good. getTE is going to retrieve this attribute here. Index 1 is going to give you a course. So now we're back to the course. And now, is this okay? So you were asking about more example. So now here, the title, right? You want to think, let me put it here. So we got prof. Let me just write it down completely for this one here. Prof.getTE index 1 dot title. In this case, why we can actually get access to this particular title attribute, which is private, is because if you look at this part over here, what's its type? Prof is faculty. getTE is going to give you an array of course, and then index 1 is going to give you a course. And this course matches the starting context. They match. So that's why you can refer to the title. Valid because the navigation context and starting context are the same. So that's why you can actually refer to this title over here. So this one is actually valid. So that's why we don't choose it. So this one might be, you want to contrast this one over here and also this one over here. Why? This one here is not valid, but this one is actually valid. You want to contrast these two, okay? Okay, the next one, let's say here, can we do that? Here, you can see up to this part here is the same. So it will still go, still go back to the course. And since we can refer to the private attributes because the starting and the navigation context actually match. And can we refer to some public accessor? Of course. So we can do that. Okay. So you can think about either we say title or getTitle. So both are fine. Okay. Okay. Finally, let's say prof.getTE.getTitle. Is this valid or not? The last one. Anybody?
It's
Is
not
this valid or not valid?
It's not valid.
No, it's not,
Why is that? Why is that not? Can anybody explain to me why?
because it doesn't do
It's,
the course.
it's an array. It has to be indexed.
Okay, good. Okay, that's exactly what I wanted to hear. Very good. So this part over here, we know that it's a faculty, right? Prof, faculty. getTE is going to be an array, like a course array. You are trying to say get title on the course array. That's not good. What we're expecting to see, maybe some index over here, maybe index I or whatever, right? So that's why it's not valid. So that should be chosen as well. All right, any questions about this this one here? Any follow-up to this? I think it's really the principle over here you want to actually know.
So just to be clear, the context never changes. It's just if the thing before the dot notation matches with what you're already inside of.
Yeah,
You
let me make it a bit more precise. Yeah, I know what you mean. So here, think about there are two things we're considering. This is one. The question says we are now trying to define some method in the context of course. So you can think about this is more like a starting context. All the navigation gonna start from this course, gonna start from this particular class. So think about this like a starting context. And then any dot notation that we have been going over, the context will switch every time you use a dot. For example, when I say prof dot, that one there is already switching from course into faculty, right? That's a navigation context, which will always change. But the starting context does not change. That's where you start developing your method. And then when you say getTE, and then getTE is actually going to give you the course array, and then you go to a particular index that will travel back to the course class again. So now up to here, it is the course navigation context, which matches the starting context. In that case, that's why we are able to get access to the private attributes. That's why.
Makes a lot of sense. Thank you.
Very good. So guys, I know it's tricky, but it's something we should know, right? I'm afraid. If you want to program in OOP, you should really know what's available to you and what is not. Okay. Yeah, I would say don't think this might only come in written test 2. It might come back again in either written test 3 or even the exam. So I would say if you really cannot really grasp this idea completely, reach out to me or ask me again during some later Q&A. You want to get it straight. Okay. I can see some hands up. John, go ahead.
Yep, sorry, just a quick question. This principle is a property of aggregation, right? So because aggregation allows us an object to be a container and a containee at the same time. But if we were doing composition, this would not apply, right? Because this can't really happen.
Yeah, I see what you mean. I would say it's a bit tricky. I would say, how about this? Whenever we talk about composition, of course, you can still use the dot notation, but we can still navigate between the the links. But remember, usually for composition, you don't really share the objects. So if you're trying to travel the links, you don't really go very far because very few things are being shared. So that's why when I talk about navigating between classes, is usually for aggregation.
Okay, perfect. I understand. Just clarifying that.
No problem. No problem. Okay, let me just. Oh, you know what? I can make this principle a little bit even better. If the context objects. Also, the context object is supposed to also matching the starting context. Okay, let me just give you one more note, and then we can move on. Okay, think about this part over here. This part here is the context objects. Context objects, which is of type course. And let's say this part over here. Just this part over here. So this is the context objects of type faculty. Okay, so we got two examples over here. Example number 1, example number 2. And why is this one invalid, but this one is valid? It is because the context object over here matches the starting context, which is course. In that case, you will be able to get access to the private attributes. On the other hand, the context object over here is of type faculty, which does not match the starting context, which is course. You can see they do not match. In that case, you cannot get access to the private attribute like a title over here. You cannot. Okay.
Sorry, just a quick question.
Yeah, go ahead.
We said, so the first time we said it's the context object is class faculty. We can't do prof.te at one because like
You cannot do, yeah, exactly, yeah.
te at one, right?
I need to box that a little bit more carefully. I see what you mean. Yeah, very good. Yeah, sorry about that. Yeah, sometimes the pen may be a little bit too thick. Let me do it again. All right. Let me erase this part over here. Okay, let me just box exactly what I meant to box. This part over here, just this part. So this part here, the context object is faculty. So now, can you get access to TE? The answer is you cannot, because faculty does not match the starting context, which is course. So that's why you cannot get access to TE. Make sense to you?
Yeah, perfect. Thank you.
Okay. All right, guys, as I said, this should not be the end. If you got any doubts, you're welcome to ask me again later, right? Okay, good. That's about the first one. Okay, let's see the second one. Okay, so for this one here, I would say if you see something similar in the test, it's more like a tracing question, okay? And I'm just using the same example that we did in the lecture, so you do have some familiarity, okay? Let me just make it a little bit bigger, and then I'll zoom out a little bit later. So we got a counter maximum value is simply 3, right? And then we know when to actually throw the exception for value too large, right? When you try to call the increments, but the current value has already reached 3. In that case, you cannot really increment any further. That's why you will throw the value too large exception. Okay. So the first one here is about, apparently this is a wrong implementation, right? We spoke about it before, right? Here you're saying that you will only throw the value too large exception when the current value is strictly larger than counter the maximum value, which is 3. Meaning that you only try to throw starting from 4. That'll be too late, right? When you're trying to increment from 3 to 4, you wouldn't throw it. But when you try to increment 4 to 5, you will throw it. That's basically what the wrong implementation is saying. Let's now try to trace it quickly. And of course, in your actual E-class question, I simplified it a little bit. I didn't include every line over here. That'll be too much. I only included some line. Okay, let's now see. Let me highlight it. Line number 3, for sure, we're gonna initialize the counter, and the value will just be 0. And then line number 4 as well, we're gonna print out the value for the counter, which will be 0. Now we enter the try block, and we're going to increment for 3 times. None of them will actually give you any exception. None of them, right? And then after that, you are going to execute line number 7, which will give you the value. And that one there should be 3, right? Okay. And then we'll go for the inner try block over here. That one there is we're going to increment one more time. Are we going to get a value too large exception? The answer is no, because currently the value is actually 3. And maximum value is also 3. 3 larger than 3 will be false. So we'll still increment the value from 3 to 4. So that's why you will actually get to this part over here, which will give you, which will tell you that it's an error in the case of console tester. Okay. So once the try block is done, we're actually going to bypass the catch block because nothing was caught, and also bypass this outer one because nothing was caught from here. Right. And then we go to the end. That's it. So the final answer should be, let me just also highlight these 2 lines, 9 and 10. So final answer should be 3, 4, 6, 7, and 9, 10. And after that, the code simply just terminates. Any question about this one here? One thing I want to mention, right? That's something I want to mention as well. It's more like a technical part of the question. Okay. So in the question, I would say, let's say first line of execution, if any, right? And also second line, third line, fourth, and also 5th. I think I gave maybe 6 or 7. I forgot. Okay, something like that. Okay, so now we should really put 3, 4, 6, 7, and then 9, 10. Okay, you're wondering about what should be this one here. Well, this is already after the code has terminated. So you just say execution terminated. And in case you see another one over here, might be the case for your question. You'll just say it has been terminated, so we don't have any further execution to be done. Okay, just in case. Okay, got question here. MD, go ahead.
Hi, sorry, could you just repeat why when you have the value as 4, it will still not give the exception error?
Which line you're talking about? Sorry. Which one?
So it's for the try increment C. So like before you did increment 3 times and you said the maximum value of the counter is 3. But now that it becomes 4, why will it not give the error? Could you just
good. Sure. So think about what's going to happen here. So after this line over here, the value for the counter will be 0. Agree? Here?
Yes.
Good, very good. Okay, let's think about the value. And the way we increment the value is at the end of the method, we're going to increment it, right? So now at the end of the first increment is going to be 1. At the end of the second increment is going to be 2. At the end of that is going to be 3. And then when we go to this particular increments, right? At this point, the value should still be 3. It's not 4 just yet. It's only going to be incremented after this if it were to be incremented. So that's why for this line over here, we still don't see any exception thrown.
Okay, so it's post increment, right? So it's like it's
yes,
not that.
yeah, the fourth increment is gonna yeah, exactly. Yeah.
Okay.
Okay. Good. Yeah, guys, be careful because I think this kind of tracing, in some way, you should really not assume any particular behavior of the program. So when I say you want to trace the program, you want to trace that faithfully according to what you're given. That's really important. Okay, we can do another example together later. Okay, so okay, okay, good. Andy, any more question for you? Oh, you're fine. Good.
Oh, no, I just sorry.
Okay, no worries. That's fine. Okay. Okay, next one. Okay, this one here, it's kind of the opposite, right? You can see now, we also mentioned that it's actually incorrectly. But guys, by the way, just for your general information, when I say the increment method is implemented incorrectly over here, since the question is really about tracing, so what I said over here, just to give you a little bit more information, tell you that this one here, we're going to trace it even though it's incorrect, logically, right? That's one point you should really keep in mind. Let's see this one here. The reason that it is incorrect is we say we throw the value to large exception too early, prematurely. When value is actually strictly less than counter the max value, which is 3. So that means we're going to throw when the value is equal to 0 already, right? That's what we know. Let's see what the execution flow will be. First of all, we're still going to create a counter, and now the value will just be 0. Okay, let me make a note over here. That'll be 0. After this, counter value will be 0, and then after this, we're going to print out the value, which will be 0. Okay, and then let's see what's going to happen. We're going to execute line number 6. Of course, here I'm being a little bit just trying to collapse everything together. But of course, when you are trying to execute this line here, you're going to execute the first one over here. That one there, when we execute it, the starting value will be 0. So 0 less than 3 is going to be true. So that means we're going to throw that exception, right? So the flow is going to be disrupted, and then we'll go to this part over here. Because you can see that the indentation tells you this try here should be matched by this catch over here. So when there's any exception that's thrown in any of these, it's going to go to this catch over here. So that is why the execution flow will be something like this, right? Let me write it down. Okay, it's going to be 3, 4, 6, and then 17. right? And then after that, execution terminated. Okay, any question? Anyone? Any follow-up? Okay, maybe the second one's better, I hope. The third one is also similar. Okay, similar. And this one here, I simply said, let's see what I said in the question. Say the method increment is implemented correctly as explained above. So when I say implemented correctly, because there might be more than one way to actually implement a method correctly. So that's why I just said it's implemented correctly. That means the increment method should throw a value to large exception when the counter's value reaches its maximum already, right? So now let's take a look. Before I do the execution flow, let's do a little bit conceptual look ahead. After this line over here, we know that the value should be 0. After this second increment, it should be 1. After that, it should be 2. After that, it should be 3, right? And this fourth one over here, we're going to execute it, but before it gets to 4, this is where we should really throw the exception because it already reaches its maximum. That's what the correct interpretation should do, okay? Knowing that, let's now see. So the first line should be create a counter and then print out its value over here. And then we go for the inner, the outer catch try block. And we're going to increment for 3 times without any exception because we assume that the implementation is correct. And we're going to print out the value, which should be 3. And we go for the inner try block. And when we try to execute this line over here, because the value for the counter has already reached 3, so that's why you're going to throw the value to large exception, meaning that you're going to disrupt the execution flow for the inner try block, right? So let me just make it a little bit more color here. Try and also catch over here. So that means you're going to disrupt it and go to, oh, sorry, not here. So it's going to be, yes, actually that's right. Because we're going to go to the catch block because the exception should be thrown here. So this is kind of expected because we are trying to do the 4th increments for the counter. So that should be success. Okay. Let me just say this. And after this, we are simply just going to go to the end of the catch block and skip. And this one here, because nothing was thrown from here, so we also bypass, right? And then go to the end and terminates. So what's the final answer? Final answer will be 3, 4, 6, 7, 9, and also 13. So that's the final answer. Okay, any questions related to 1, 2, and 3? These 3. Any questions? I think the purpose of these questions are to see if you're able to know the precise execution flow of the program. Because whenever you got try and catch, you got exception that's possible to be thrown, you definitely got 2 possible ways to go. Either you go for the normal flow or you go for the abnormal flow. It's really important for you to know exactly which way to go, right? So that's the purpose for these questions. Anyone? Okay. Okay, let's now look at, we got 2 more. Okay, the next one. The next one here, we're assuming that we actually got point v1 and also we got point v2, where both of them got private attributes x and y. And also we got the equals method being overridden in point v2. The same setup as in the lecture. Okay. And let's say what we want to do is let's assume the following object creation, P1, P2, P3, P4, and etc. Right? So why don't we visualize them very quickly? Okay. So we got P1, P2, P3, P4. Okay, let me now do that. And that's something you should know as well. Well, if you can visualize in your head, feel free. But for me, just for everybody's benefits, let me just do that quickly. Okay, it's going to P1. The type is going to be point v1. And we simply got 3 and 4, right? I'm just going to write it this way, 3 and 4. And P2 is going to be very similar, except that it's going to be a new objects rather than just P1, right? Let me just put it here. Okay, so this is going to be P2. And also we got P3 and P4. So let me use a different color to tell you it's a different type. Let's say this one here is green. And the type should be v2. Point v2. And that should be p3, right? So we're talking about this line here. And we got another one, p4. So there'll be 4 objects in total to be created. Okay, so this is p4. p4 over here. Okay, we still got p5 and p6. p5 and p6, right? p5 is going to point to wherever p2 is pointing to. p5. Also, p6 will point to wherever p4 is pointing to. All right, that's a visualization that I will expect you to actually do, when you answer this question here. Or you can do it in your head if you're able to, okay? Let's now consider, we want to choose all those that will fail. All right? Let's see how we do that. Let's see here, assert not the same. P4 and P6. So let's see, P4 and P6, are they the same objects? They are the same objects. So that's why when you say assert not the same, it's going to fail, right? So that's why we're going to choose it. Okay, the first one. The second one, let's say assert the same, P4 and P6. P4 and P6, are they the same objects? They are. So that's why it should be passing, right? So we don't choose it. Next one, assert equals P2 and P5. P2 and P5. Anyone? Should this pass or fail? P2 and P5.
Pass.
Huh? Pass, okay. Well, in some way, it's really easy because they point to the same objects. But you should really know, when you say assert equals P2 dot P5, let me just remind you, this one here is going to call P2 dot equals P5, right? That's something we said in the lecture. P5, and we know that P2 is actually of type point v1. So we're going to call the default version of the constructor, which will actually boil down into comparing P2 equals P5, but they happen to be the same object, so that's okay, right? So that will pass. Okay, the next one. Assert the same P1 and P2, right? Apparently that will fail, right? P1 and P2, they are different objects, even though their contents are the same, but doesn't matter, right? You want to go with the assertion that you're dealing with. So this should be failing. What about assert equals P5 and P6? Assert equals P5 and P6. It looks like their contents are the same, but is the assertion going to pass or fail? Anybody?
Fail.
No? Why would it fail?
Because the dynamic type is different, right?
Aha, very good. Exactly. That's exactly right. However, I want you to be a little more careful over here, to be more precise. Okay. Let me ask you this. We know that this will boil down into calling P5 dot equals P6. Can you tell me which version of the equals method will be called? Is it the default version or the overridden version?
The overridden version.
How do you tell?
Default version.
Actually, no. Yeah, the P1, the point v1 version.
Okay, I agree, but why? Can you tell me why?
Because the context object is point v1.
Very good. Very good.
Point v1, we don't override the equals method.
Exactly. So that would just use the inherited one from the object class. Exactly right. Good. Just be careful. Okay. So here, this one here, P5 is of type point v1. So that's why we're going to call the default version. So this will boil down into P5 equals P6. So that means this one is going to fail for the reason that P5 and P6, they are different objects. I remember you first said to me they are dynamically different types. That's not the reason. Okay. So that's why I want to correct you more precisely. So here, P5 and P6, they are different objects. So that's why it will fail. Okay. So because that will fail, so we're going to choose it. All right, let's now go further. Assert not the same P1, P2. let's say P1 and P2, they are not the same objects, I agree. But since we say not the same, so that will simply pass. So we don't choose it. Okay. And then next one, assert equals P1, P2. Okay, now anybody want to tell me assert equals P1, P2? Should it be passing or failing?
False. It'll fail.
Fail. Why?
P1's point V1, so it uses the default one, and they're both clearly not the same object. So
Exactly. Very good. So this one, yeah, just for everybody benefits, I'll just write it down. So that'll be P1 dot equals P2. So guys, as you can see, the main strategy for answering questions related to equals is to think about whether you're calling the default version or the overridden version. And once you know the answer, you want to see what it boils down into. Compare references or comparing contents. That's really the strategy. All right, so now we know P1 over here is really this type over here. So we know that it's calling, as you said, the default version. It will boil down into P1 equals P2. So they are different objects. So they're going to fail. So that should be chosen. Okay, we got 3 more. Let's take a look. What about, let me use maybe purple here. How about this one here? Assert equals P3 and P4. That one, let me save you some time. That one should pass, right? Because that will boil down into P3 dot equals P4. And P3 is of type point V2. So we're calling the overridden version of the equals method. In that case, we compare x by x, y by y, so they should pass. So we don't choose it. Okay. Next one. Assert not equals P3 and P4, right? Well, basically this one here, because this one here will pass, so that means this one will fail, right? Because it's just not equals. You can think about assert not equals, simply just try to assert the opposite, right? Because we know P3 and P4 should be equal, so when you say assert them not to be equal, it will fail, right? Okay, finally, let's now look at this one here. Finally, assert equals P6 and P5. Okay, P6 and P5. And for this one, I would like 2 answers from you. If anybody would like to volunteer. Number 1, should it pass or fail? And part 2, tell me exactly how it pass or fail.
Should fail. It should fail because the dynamic, when it compares dynamic type of.
So why would they compare the dynamic types? Why?
Because you want to get the class, and class gets the dynamic type. Because P6 is point V2.
Okay, so you are implying that the overridden version of the equals method will be called. Is that correct?
Yep.
Okay, good. Awesome. So this one here is going to boil down into P6 dot equals P5. So I think that this example question is rather nice. You know, just not just for your test. I think for your knowledge in general, it really summarizes different scenarios that you're supposed to know about equals method. That's something I care more. So here P6 over here, dynamic type is point V2, meaning that we're going to call this version the overridden version of the equals method, which means at some point you're going to compare their dynamic types over here. In that case, P6 and P5. You can see P6 and P5. P6 and also P5. Their pointed objects simply dynamic type is different. Point V1 versus point V2. So that's why it should be different. Okay. So that should be false. Especially for this line over here. Okay. So that means it's going to fail. All right. And what I want you to really contrast is this. You want to contrast 6 and 5, this one here, and also, let me see the one I want you to look at, 5 and 6, this one here. Yeah, I'll let you to review this again. I want you to really contrast this and this. Both of them will actually fail, but they fell for different reasons. Okay. Okay, I got some question over here. Mohammed.
Yeah, so I have a quick question.
Yeah.
In point V2, and when we go inside the equals method, the third if statement, it says
the third one.
this if the get class of this and obj are are not equal, then it returns false, right? And when you're explaining it, you basically explain that if it returns false, then the dynamic types are different.
Correct. Correct.
But can getClass, does that, no, wait, let me rephrase. So
it's okay, take your time, you can rephrase it.
Does the dynamic type, if the dynamic type are similar, does that also imply that the class of the two objects are also similar?
Yes, roughly, yes. Okay, so think about this getClass is going to give you so-called. I'll say that briefly, and I'll refer you to maybe one of the recording, one of the part of the clarification we did earlier. I'll refer that to you. So this part here is going to see this. Let's say we talk about this example here. Let's say P5 and P6. So context object will be P5 over here. So when we say P5.getClass, we can say P5, according to our tracing, its dynamic type is point V1. That means you're going to give the information objects for point V1. Versus obj.getClass. Obj is the argument, which is P6 over here. So what P6, according to our tracing, the dynamic type is actually point V2, meaning that it's going to return the information object for point V2. So now we are comparing the information object for point V1 versus the information object for point V2. They're different. So that's why this part over here is going to be evaluated true. So that's why it's going to return false over here.
Okay, and I have a slightly different question, but related to the same thing.
Go ahead.
Can we have different dynamic types, but from the same class?
Can we? Yes, that's about inheritance, which you will see in week number 7 lecture.
Okay.
Yes.
Thank you.
Yes, definitely. You can having the same static type, but you may reassign the reference variable to different dynamic types, as long as the dynamic types are, which we'll see in week number 8, as long as the dynamic types are descendant classes of the static type. Right? You may not know what I'm talking about because you haven't studied week number 7 yet. Please do that, and then you will see exactly what I meant. All right. Before I actually go to the next question, just bear with me. I want to point to Mohammed, actually for everybody's benefits as well. Okay. I would say please go to I forgot which one it is. Let's say if you go to week number 5, okay, maybe go for October 20th. Go there. Okay, I will show to you what you can look at. And then you see under the roadmap over here. Okay, not here, sorry. Maybe another one. If you can go under October 21st, go there, okay? And then you will see that under the roadmap, and I want you to look at this part over here, the getClass. Let me see where it is. Static type. I think somewhere I talk about. So am I just missing that? Okay, October 20th. Over here. Sorry. So Mohammed, and also for others who are interested, go under October 20th recording and go to this topic. Understanding the getClass method for returning dynamic type. I think that one will explain further about your doubts. Okay, just to mention. If you're still here. Okay, good. That's fine.
Okay, thank you.
No problem. All right, let's now go back. Okay, let me just answer further question. Sorry, I'm not sure how to pronounce your name. Forgive me. Harsimran. Go ahead, please. Yeah.
For the option H over here.
Option, which option, sorry?
H.
H, okay.
Yeah, it's assert equals P3, P4.
Yep.
That would pass, but my question is, what if it was assert equals P4, P3?
Okay, sure. Okay, let me write it down, and then I'll let you try first, and then we can, okay, let's see. You were asking about, what if we say, assert equals P4, P3, right?
Yeah.
Okay. Okay, what's your thoughts?
My thought is that I think it would pass.
Okay, I think that the answer is correct, but why? Why would it pass? Especially tell me which version of the equals method will be called.
Which version of the equal method? It would be the
default version or overridden version?
No, the point v2.
Sorry, say it again. Overridden?
Yeah, the overridden one, yes.
Okay, so why is the overridden version called? That's also very important.
Well, first it's because it's defined as point v2, right?
Point v2, yeah. Okay, so I think you're jumping one step. So my question is, when we try to say assert equals over here, why is the version of equals method that's defined in point v2 will be called? Why? Is it because of P4 or because of P3?
P4.
P4, okay, good. Because that one boils down into P4 that equals P3. And to determine which version will be called, we need to look at the context objects. So that's why. Right? So you can see here, in this case, either we say P4, P3, or we say P3, P4. The context object, either P4 or P3, their dynamic type is simply point v2. So the same version will be called. So it doesn't make a difference.
Okay, so, okay, I see. All right.
Okay, yeah, it's a good question. All right, John.
Yeah, sorry, just a quick question. So when we were given the equals method for point v2, we assumed it's like the normal equals method for point v2, like for just like the overloaded version that we have. But if like, let's say there's some like the implementation we were given has like an error, but the error would only come out when like do certain things. Let's say we didn't have the if object equals null return false. If we didn't have it, and we had just that first and third if statement, but that error would only come out in certain assertions. Would that be like a possibility where they would fail assertion because the error will be thrown, but only because the implementation is different?
I think we might need an example from you, but I think maybe you're saying that what if the equals method that's overridden was implemented incorrectly? Is that what you're saying?
Yeah.
Okay, so I would say depends on what kind of question we're asking, right? If there's only a tracing question, I say now let's say a trace tell me the result for assert equals, let's say P1 and P2. Let's say P1 dynamic type is point v2, let's say, and point v2 somehow I gave you some wrong implementation for the equals method. In that case, you just have to go through line by line to see what the output should be. In that case, you cannot assume it's actually implemented correctly.
Okay.
Yeah. Okay. All right, guys. I think we got. You got more. Yeah, go ahead.
When an error is thrown, it fails assertion, but like let's say like we assert equals with like let's say like P6 and like null, and we didn't have that if statement, and that throws an error. That will fail assertion, right? Or would it just stop because of the?
Yeah. Okay, if you say assert equals, let's say P6 and also null, let's say, okay, if you do that. If you do this, let's say, for example, let's say you do this, it's a good question. Okay, hypothetically, let's say you got this, and let's say that one is going to call point v2 version. Hypothetically, let's say we didn't have this line over here. John, that's what you meant, right?
Yep, exactly.
Okay, good. Tell me what's going to happen if I didn't have this line.
So I'll come to compare the class. I'll come to compare the class of P6, and then once it tries to get the class of null, that's going to cause.
Exactly. Okay, just for everybody's benefit, I'll write down slightly. Okay, but John, that's a good question. Okay, let's say if you try to do this, okay, and then hypothetically, let's say we got rid of this line, hypothetically. In that case, null over here is going to be the obj. If you say getClass, null.getClass, that's going to give you null pointer exception. Right? So if that was a tracing question, you should really tell me that we're going to fail the test because we got some null pointer exception that's unexpected. So John, I hope that answered your question, right?
Yep, it does. Thank you.
Very good. All right, guys, let's we still got a few minutes. Let's now, for completeness, let's go over the last one quickly. That one is mainly about the short circuit effects, which I review in the equals method, right? I said that was optional, meaning that you should only skip it if you feel confident about a short circuit effects. If you don't feel confident, you should also review that lecture. Okay, that's what I meant by optional. Let's say this. Okay, let's take a look. Assume a non-empty integer array ns of length 3. Why don't we visualize that right away? Ns is an array of size 3. Indices 0, 1, and 2, right? So that means ns.length is equal to 3, right? That's what we know. And then let's say consider the following fragment of code. Let's say this is what we have, right? This is supposed to be a short circuit effect question, right? So now let me make it straight to the point. You can see here we are trying to do this expression over here, NSI, right? NS, the array. Whenever you're doing some indexing notation, NSI, for example, over here, this one should be guarded. That's what we talk about guarding constraint. And when we talk about the short circuit effects, the order of evaluation at the runtime will still go from left to right, meaning that we're going to go for this one here, and then this one, and then this one. Apparently, you can see this is one guarding constraint. Meant to be. Okay, so this is one guarding constraint. This is one guarding constraint to make sure any value, if that is saying that I must be larger than or equal to 0, meaning that we want to prevent -1, -2, -3. Those values should really cause this part over here to be false, meaning that we will not go any further to evaluate the right hand side of the conjunction, right? That's what it is supposed to do. And this one here is also meant to be a guarding constraint, but it just placed in the wrong place. I'll talk about it in just a moment. Over here we say that I must be strictly less than ns.length, must be strictly less than that, meaning that it cannot be too large. Okay, so that means if it that's also another guarding constraint to make sure if it is equal to 3 or 4 or 5, that will also cause this part over here to be false. But the problem is, for this constraint over here, you're only putting that after the condition the indexing you want to guard. That's wrong. So this one over here is actually placed after the indexing notation that is supposed to be guarded. So that's actually wrong, meaning that you can only find out the value may be too large for the index after you have evaluated using that index. So that's a problem, right? Let's now go over the question. The question is, when executing the above program, which of the following value or values will result in an array index out of bound exception? Basically, any value that's going to make this false is going to be a problematic because we only check it after we have used it for the indexing notation, right? So now it can be anything that's is actually larger than or equal to the length of the array, which will be 3, right? So that's why 4, and also I think a 4 should be the case, right? Let me see. That should be the answer, I think. Let's go over one by one to be more careful. Okay, let's go over the first one. Is value 2 going to fail? Number 2 over here, you can see. Let me just go write down the expression here. Let me be careful. I don't want to rush it. Yeah, we'll go over one by one, and then once we go over the first few, you will have an idea how to complete the rest. Strictly less than ns.length. Okay, let's now go carefully. Let's say the first one. And by the way, we know that ns.length is actually 3, right? That's something we know. If I have 2, 0 less than or equal to 2 is actually true. So we should go and evaluate this expression over here. In that case, n is 2. Is that valid? It is valid because 2 is a valid index. So that's okay. So this one, we don't choose it. Okay, let's see the next one. What about, let's say, 4 over here? So 0 less than or equal to 4 is actually true. And we are going to actually evaluate n as 4. And do we have that index? We don't. So that one is going to fail. So that's why we choose it. Okay, let's now go one more. Okay, what about 0 over here? 0 less than or equal to 0 is going to be true. And we're going to go for ns at index 0. Is a valid index? It is, indeed. So there's no array index out of bound exception, so we don't choose it. What about -1? 0 less than or equal to -1. True or false? It should be false. So that means it's going to be false, meaning that we're not going to go ahead and evaluate the rest. So indeed, this one here can really prevent any negative value indices to be from being used as an index. So that's why this guarding constraint was put in the right place, whereas this guarding constraint was put in the wrong place. So this is okay. So we don't choose it. All right. So you can see 3 here is also, by applying the same logic, you can see 3 is actually a valid index, right? So this 3 here, you will see just the same as 0 less than or equal to 3 is going to be true. So we're still going to evaluate ns at index 3. So that'll be that'll be actually invalid. This one here, 3, 0 less than or equal to 3 is actually true. So that means we have to evaluate this part here. And then we say ns at index 3. Is that a valid index? It is not, because we don't have index 3. So this one should also be chosen. Okay, one more. -2. 0 less than or equal to -2 is actually false. So we don't have to evaluate this expression here. It's been guarded. Finally, what about 1? 0 less than or equal to 1 is actually true. And we have to evaluate this. ns at index 1. It is valid, so we don't choose it. So it ended up, we're going to choose 4 and also 3. Okay, any question about this? Anyone?
While answering the question, right?
Mm-hmm.
To make it easier for us to like actually comprehend the question and understand it properly, can we like divide the different possible cases? For example, we know that there are 3 different cases.
Mm-hmm.
There's one case where the interval is between 0 and 2. And then the other case is if it's more than 2, and the other one is if the number is negative. So if we divide it into those 3 cases, is it a better way to go about answering the question?
I would say, to be honest with you, if even for myself, if I were to solve this question myself, I'll definitely, first of all, I'll visualize the array to know what indices are valid. That's number 1. Number 2, I will simply plug in the value for each one of them and then figure out which one is going to result in array index of out of bound exception. That's how I would do it. But if I really have enough time, in that case, I can do a little more analysis, like in this way. Because this guarding constraint is supposed to block -1, -2, -3. So that means all these values, like here, -1, -2, so they should not be chosen because they are being guarded. And they would simply cause this to be false in the very beginning. So we never get a chance to use them. On the other hand, I know that this one is being misplaced after the expression that should be guarded. In that case, we know that we will the guarding constraint is supposed to guard like a 3, 4, and 5. But now since they are misplaced, so those values should really result in array index out of bound exception. So that's why we said 4 and also 3 should be chosen. That's another way to see it. But as you said, to really divide about the interval, you can try that as well. That might also work.
Okay, thank you.
Okay, good. All right, any more questions? All right, so good luck to your written test 2. And then I would say after written test 2, make sure you actually catch up with your lab 3 and also for your week number 7 lecture about inheritance. Is really crucial. So John, we are running out of time. How about you drop by my office hour? Would that be okay? Okay, sounds okay to him. Okay. All right, guys, I'll see you later. Take care.